Hello, am I audible now?
Yes, ma'am.
Hmm?
Yes, ma'am.
Okay, let others join then. Hello, am I audible? Am I audible now properly?
Yes, ma'am.
Am I audible?
Yes, ma'am.
Yes,
Hello?
ma'am.
Audible?
Yes, miss.
Yes,
Okay.
ma'am.
Okay. I think we have done this, the process of transporting, how we could have transported either by mortar pen, we have wheelbarrows, we have belt conveyors, then we had the cranes and buckets, pumps, transmit mixtures. We have already talked about this. Okay. Now the next step was after transportation, after transporting the concrete, we will place them and then do the compaction of concrete, right? So compaction why we do, so that we can remove these entrapped airs from the concrete. Okay, like when we were doing the mixing, we were doing the transporting, we were placing them to their places, what happens, air gets entrapped in the concrete, and so compaction is very important for removing the entrapped airs. Okay, and one more thing, like why we need to do the compaction and why we need to remove the airs, because 1% there is a chance of 1% of air in the concrete. If it's present there, then your strength of the concrete will get reduced by 6%. So that our we don't want that our strength of the concrete should get reduced anyhow. So we do the compaction such that we try to remove the entrapped air with the help of compaction, so that our concrete remains at its own strength. It does not reduce its strength due to the air present or entrapped in the process of mixing, transporting, and placing of the concrete. Okay, because if we don't expel the air, what will happen? It will result in the honeycombing or reduced strength of the structure. Now, honeycombing means what? Honeycombing means when in your structure, what happens? There are some voids present in your structure. So that is nothing but that is called your. You will see some whole kind of thing like voids in a structure. So that is nothing but that is called your honeycombing. Okay, now what are the different methods of concrete compaction? The different methods of concrete compaction is, one is your hand compaction, the other one is your compaction by vibration. Okay, so hand compaction, it can be either with the help of this rodding, ramming, or tempering. Okay, so what is your rodding? With the help of this rodding, we use what? We use the rod to compact the concrete. We use here in the second one the ramming. Okay, we use here the tamping. Okay, now for the compaction by vibration, we use either internal vibrator, formwork vibrator, table vibrator, platform vibrator, or surface vibrators based on our purposes and the conditions. Okay, so I'll show you the things. Like the first one was your hand compaction. You can see here one rod is used for the compaction of this concrete here. So hand compaction is used for ordinary and unimportant structures, like you can say workability should be decided in such a way that the chances of honeycombing should be minimum. The various methods of hand compaction are as follows as given. This is the hand mixing one, which is your hand compaction is generally why we do the when we do the hand compaction. Obviously, with the compaction when we are doing with hands manually, what will happen? Our the compaction, the required compaction which we want will not be achieved. Okay, will not be achieved, and the airs may stay entrapped in your concrete, which will obviously reduce in the strength of the structure, which will result in the reduction in the strength of the structure. But on the other hand, when we do the machine one compaction, that is far much better, because as compared to your hand compaction, when we do the machine compaction, what happens? Our entrapped air gets reduced much more than in the hand compaction. But also when
Means
we
your
are
voice is
doing,
breaking again.
huh?
It breaks in the middle just now. It was breaking too much and we couldn't hear anything.
I think some this thing, the construction is going on by our side. Some of the works are going, so that's why maybe noise is there. Now am I clear? Hello?
Yes,
Hello.
ma'am.
Okay, hand compaction. So as compared to your machine compaction, your hand compaction will not give you the strength of the concrete as compared to your machine one. But when we cannot use the higher machines for our construction purpose, and our it is less important, the structure which we are considering is less important, like you can say the walls of the uh, outside walls of your lawns, etc., that also you don't need so much. So if you're using concrete, then it is, you can do hand compaction also, it's okay for that. Okay, so we have the first one, the hand compaction is what? Your rodding. Rodding is what? Here we use this method of poking with a 2 meter long, 16 diameter rod. Okay, this is a rod which is 16 diameter of 2 meter long at sharp corners and edges. Here at the corners, we compact, we poke it, and then on the edges also. The thickness of the layers for rodding should be 15 to 20 centimeter. Okay, so when your condition is such, then we use this rodding. Next, we can use either rammer. This is your rammer. We can also use rammer, or we can use the tamping. So you see here, the rod, the compaction which we do, hand compaction, the first one with the rod, that has a very less diameter, and obviously you only poke to only the sides and corners. So what about the middle portions? It may be left out, and in the small area, small surfaces where you want, you can use a rodding. But here ramming is done where, when you want your general compaction on the ground in plain concrete. Okay, not the it is not used in RCC or on upper floors, it is only for plain concretes it is used. Okay, and tamping, where it is done, this is a tamper which is a greater, which is much more bigger than your tamper, oh sorry, much more bigger than your rammer. Okay, so tamping is what? It is we tamp with this. Okay, top surface of this is beaten. It is a method in which the top surface is beaten by wooden cross beam of cross section 10 centimeter into 10 centimeter. This one is your 10 centimeter into 10 centimeter. Both compaction and leaving are achieved simultaneously. Okay, it is mainly used for roof slabs and road pavements. This is bigger than your rods and the tamping when we do it manually. So earlier we used to do this also, or in some areas of your pavements you can do, or in your nearby to the lawn only you may provide some pavements, that those small works also you can use this manual hand compaction of by tamping. Another, now after the hand compaction, we, I said you, for unimportant works or less small construction works, we use that manual one. But what about the bigger ones? So we do that, in that case we do the compaction by vibration. And what is that? Vibration is important to the concrete by mechanical means. It causes temporary liquefaction so that other bubbles come on the top and expel ultimately. Okay, mechanical vibration can be of various types as given under. Internal vibration, I showed you in the slide before that, previous slide, what was there? There were different types of compaction by vibration, which was your internal, this one, internal formwork vibrator, table vibrator, platform vibrator, and surface vibrator. So we have here internal vibrator. It is most commonly used technique of concrete vibration. It is the most common one. Okay, because what we do, internal vibration means what? We achieve this by placing the vibration vibrator inside the concrete, and then after placing it, we vibrate it such that it enters to the specified point and then there is no expel out the air. Okay, vibration is achieved due to eccentric weights attached to the shaft. The needle diameter varies from 20 mm to 75 mm and its length varies from 25 centimeter to 90 centimeter. The frequency range adopted is normally 3500 to 5000 revolution per minute. Then we have the correction and incorrect the correct and incorrect methods of vibration using internal vibration needles are shown. Okay, I'll show you now that this is the diameters of your the needle. Okay, which is with the help of which you're going to compact this one. You see this, the needle here, this is the needle, this is your vibrator, this is your motor. Here you have, with when you pour the concrete here, you want your concrete to get inside your you need to prepare the concrete, sorry, the concrete slab. So you need obviously that your concrete gets placed here properly and it moves inside the reinforcements properly without any air being entrapped here. So we do what, after placing this concrete we will give this vibrator, we'll put this vibrator inside so that there is vibration and all the uh, any gaps whichever is present between the concrete will be removed and the concrete will enter again. Okay, inside that we have here, mm, you can see when there is no vibration, when you don't do the vibration, when you're placing the concrete and you don't do the vibration directly, you just let it cure. So when you do such, what happens, there are so many gaps, you see. There is one gap, these are your voids. Okay, these are your voids. Then when we do the radius of influence, incorrect, this is very incorrect, incorrect, very small needle. When you have this needle for vibration is very small, it's not between 10 20 mm to 75 mm, then what happens, there remains many voids. Okay, inside the concrete. And we have incorrect small needle, see very small needle, this is the gap, so much gap is there between these voids or aggregates. Then we have, for the small needle we have what, this one. For the large needle 20 mm to 75, we have the correct and the exact size needle. Then what happens here, there are not much voids. Okay, in this particular area only two voids are there, here only one void is there and such. So it is comparatively less, in this much size it is more. Okay, your correct method is this way. That means when you are vibrating here, this is your needle you are entering here, this should be the radius of vibration is equal, straight it should be. Okay, but if you suppose you enter this needle uh, in an angle this way, from here 45 or 35 angle, and this side also, what happens here, your void will remain. Okay, the air entrapped here will remain here because you're vibrating this side will be vibrated and this side, but this portion is left out, and same for here also, this middle portion gets left out. Okay, so the air entrapped does not get removed from the concrete. So the perfect way and the correct method is straight, you have to enter this much. Okay. Mhm. Next, we have your external vibrators. That was internal vibrators. We used to put the needle inside the concrete and then we used to give the internal vibrations, right? But here, next vibration, which is made by machine vibration, is what? It is external. It is adopted where internal vibration can be used due to either thin section or heavy reinforcement. When you have a large reinforcements, you cannot put with your hand, you cannot go with your hand and all the time you cannot put the needle inside and then again vibrate it. You have a large reinforcement area is there, right? So you cannot use that part. But and also for thin sections, because thin sections you don't need only. So external vibrator is less effective and it consumes more power as compared to the internal vibration. The formwork also has to be made extra strong when external vibration is used. When we are using the external vibration, these things you remember, internal vibration is more um, effective, okay, as compared to your external vibration, because external vibration means what, when you are placing this machine here, it will vibrate your this thing, the formwork. Okay, so that your there is the extra airs which is entered, it gets removed. But internal one is what, in each place you do this distance, you just check that here there is no, it is efficient, right? Because at small distances you give the internal vibration, you make sure that the air is not there. Okay, but that is not in this case external. Just you vibrate the structure or the member here, you vibrate the member, and what happens, uh, whatever is to be removed, the entrapped air, it gets removed, but there might be some uh, voids as compared to internal one. Okay, there is another vibrating method, which is your table vibration. Now, what is a table vibration? It is mainly used for laboratories where concrete is put on the table. When we need to pour the concrete in table such so that the entrapped air gets removed, we want to make sure that our entrapped air is removed, and then we use that concrete for suppose making concrete cube, or for any other members you want to construct, or you want to make any other concrete material for experiment purpose. Then we do this, we can use this table vibrator, okay, where we vibrate and then the concrete gets flattened here with remove after removing of the extra air entrapped here. Another one is a platform vibration, which is similar to the table vibration, but it is for large construction or in large scale. When we our work is on a large scale, we use this platform vibrators. Like we want for a ready-made suppose the slabs, so in a huge member, so we can use this platform vibrator for our compaction purpose. Okay, now the next one is your surface vibration, which is, these are also called screed board vibrators. The action is similar to that of tamping. How we used to tamp, right? We used to do the tamping in this way. This one we used to do the tamping, we used to give these things, we used to compact it from a height, certain height, and we used to compact it, okay, using this temper. So surface one is same here. In the surface vibrator, what we do, it is same like compaction, only you have two handles here. Okay, action is same, right? You have to this thing you have to compact with this portion. Okay, but the vibrator is placed on screed board and the vibration is given on the surface. Okay, it is mainly used for roof slabs, road pavements, etc., but it is not effective beyond 15 centimeter. For lesser depth of construction, you can use this surface vibration. Okay, so this was your manufacturing process of your manufacturing process of your concrete, which was how many, we have seen what, we have seen the this one batching, we have gone mixing, transportation, placing, compacting. Okay, these things, this was your manufacturing process. In this way you manufacture. Now when we go, we let me go and see where is the other part. I think I have stopped sharing now. Now we'll go to the types of concrete. Okay, where is the wait. Mm. Once we know now the procedure for the manufacture of cement, after compaction we can directly keep it for curing and then we give the finishing. Okay, but when we do the types of concrete, we have concrete, there are different types of concrete, okay, which are based on your binding material, cement or lime it can be, but the main, tell you this one, I'll show you. I'll share the screen once again. Now these are your types of concrete, okay, and its uses. So classification according to design of concrete is how much? According to the design, we have what type of concretes we have. We have plain cement concrete, we have RCC, the reinforced cement concrete, and we have the PCC, which is the pre-stressed cement concrete. Okay. I think you know these things properly, but still you need to know this in your material testing class also. So I'll just tell you. Okay, so plain cement concrete we have based on the design we have plain cement, RCC, PCC. Now, what is your plain cement concrete? Your plain cement concrete is which is that which where you don't require any reinforcement. Okay, reinforcement is not provided. It is only the cement concrete. Okay, we have the cement, we have the coarse aggregate, fine aggregate, water. So, but we don't have the reinforcement. So it is your mass cement concrete or plain cement concrete. It is known as such. Okay. So this type of concrete is strong in taking compressive stresses but weak in taking tension, because we know that our concrete is weak in tension but very good in taking the compression. And also this, obviously if you have plain cement concrete, there is no reinforcement, so they cannot take the tensile tension, they cannot take, they can only take the compression. And where this is used in, commonly used in for the foundation work and flooring of the buildings. Okay, next is your reinforced cement concrete, which is your where we use the reinforcement. Okay, we have the plain cement concrete. Okay, we had the plain cement concrete where we did not use any reinforcement, but in the reinforcing cement we have what? We have reinforcement embedded for taking the tensile stress. Okay, that is why it is called reinforced cement concrete. In this type of concrete, what happens? The steel reinforcement is to be used generally in the form of round bars. We know already that we when we do the reinforcement we keep how much? 6 mm to 32 mm dia. It can be because for different members of the construction work you use the RCC. Okay, so based on that, our diameter of the bar will depend upon this 6 mm to 32 mm. This concrete is equally strong in taking tension, tensile, compressive, and shear stresses. Usual proportion of ingredients in a RCC are 1 part of cement, 1 to 2 part of sand, 2 to 4 part of crushed stone or gravel. RCC is commonly where it is used, it is used commonly for construction of slabs, beams, columns, foundation, precast, concrete, etc. In all the in all the types of construction works, we use RCC maximum kinds of works. Okay. Now, next was what? Next was your pre-stressed cement concrete. Earlier, I think in some class I have talked about this pre-stressed cement concrete. Can anyone tell me what was your pre-stressed cement concrete? I had talked, I have explained you in the class, last classes, I think. What is pre-stressed cement concrete? Hello? What is pre-stressed cement concrete? In the past classes, I have explained you this thing. Anyone? No one.
Um, uh, the reinforcement are stressed before the concrete is cured, I think.
Mm-hmm.
Reinforcement bars are stressed before the concrete is formed.
Yeah. What we do is not a reinforcement exactly, but in pre-stressed cement concrete we use tendons. Okay, tendons are like the wire strands, very huge wire strands which are made of different number of wires together. These are your cables. Okay, so those are given tension and then again released so that compressive stresses are already developed there. Okay, so I'll show you. Why this is not going. This was the reinforced cement concrete. Then we have reinforced cement concrete. This one RCC, where you use your this rods are there. So these are your RCC. Some pictures of RCC. So now what is pre-stressed? Your pre-stressed concrete was what? The cement concrete, in which high compressive stresses are artificially induced before their actual use, is called pre-stressed cement concrete. Because earlier I told you, like before any load is applied, when we use this when we stress the concrete, how we stress? We Because we give tension. Okay. So what we used to do in the pre-stressing concrete, in the pre-stressed cement concrete, we used to artificially give tension to our member. We used to pull the tendons which were present here at the within the member. So we used to give tension, we used to anchor them, then we used to release them. We used to cut these tendons and then they used to again get stressed inside, and then as a result of which here it was stresses were already developed. But now what about those stresses? What will they do when there is any external load applied? These stresses are going to, which are developed inside, are going to resist these stresses, and therefore as a result of which there will be no stresses due to this external load. Okay, for normal RCC structure, what used to happen here, rods were there, no stresses are developed beforehand here. So once the loads, external loads used to fall on our member, what would happen? This concrete would have got stressed. Okay, compression would be here. Once this, as soon as this load, external load would fall on the member, so what will happen? Due to this falling of the external load, here stresses would have developed and your member would have come under compression. But here in the pre-stress, what is happening? When we already develop here stresses before any external load is applied, so these stresses will resist this. Because suppose this is 40 kilonewton coming 2020, 40 kilonewton is coming on the from the top on this member. What will happen? Already developed stresses which are present here, that is also 40 suppose. So now when this load is applied from top, and also you are having this loads 40 kilonewton, so obviously it is compensated. So now your concrete is not in stressed, it is not under compression, because already this which should have been, due to this your concrete should have been under compression, but this is not in compression now your member. Why? Because already developed stresses has compensated these, they resisted these forces, and therefore as a result of which here there is no tension, sorry, compression under this member. Okay, this is nothing but your pre-stressed cement concrete, known as your pre-stressed cement concrete. In this type of cement concrete, the high compression stresses are induced by pretensioning the reinforcement. See, as I told you, this one I'll remove. Why it's not getting? Okay, compressive stresses are induced by pretensioning the reinforcement before placing the concrete, and the reinforcement is released when, yeah, same thing, whatever I told you, it is written here only. So we have what now, the uses of this pre-stressed concrete is what? This concrete can take a high tensile and compressive stresses without development of cracks. Yeah, obviously, because since your, it is already compensated, now another next load you can give it here. So it has a higher, very much high, they can develop, they do not develop cracks because they can resist those loads which are coming on them. Okay, the quantity of reinforcement can be considerably reduced by using this concrete. Yeah, when we use this PPC, we can reduce the amount of the concrete used, because they are always PCC is precast cement concrete is always used with a high grade of concrete. Okay, so higher strength, which has a higher strength, so we can reduce the quantity also of the concrete member. Okay, so I'll show you now. These are your precious cement concrete, you see. This is a tendon, huh? This is the inside portion of the, this is the inside portion of your, okay, let me, I'll share with you one link, okay, for your attendance. And that link will be open for 10 minutes. If you, those who are present, you give your attendance there. Uh, Here itself I'll share, wait, on the meeting. Are 03 PCC CE and 207. Okay, I'm sharing here. Okay, yeah, everyone go to the link and then give your attendance here. Use this link for giving your attendance. Okay, I'm checking your attendance here now. Okay, everybody is giving. Bamang, Mojes, Imli Sangla, Imsong, Hukavi, Tadar, Suraj, Lakshya Jyoti, Prashanta Debarma. Don't give your attendance here. Okay, I have shared you the link. You go to the link and give the attendance. Here, this is the link. Check your chat box. You will see in the chat box a link. Just go to the link and give your attendance here. This one. I have shared once again the link for your attendance. For 10 minutes, your this link will be open. After that, it will be closed. Okay. So till then, let me to show your